Yes, Abdullah. Okay, I will draw that again. So what you have, these are the walls. And this one is a positive terminal. This is negative terminal. And you have molten aluminum oxide, which is called alumina. So this contains aluminium ion, and it also contains oxygen ion. Aluminium are positive, attracted towards cathode, means towards base or towards the wall. And oxygen is a negative, it is attracted towards the anode. The melting temperature is 1900 degrees centigrade. This temperature is too high. So the equation, when we write for cathode, aluminum is attracted towards cathode. So aluminum, when it is attracted towards cathode, it will gain electron and it changes into aluminum metal or atom. And what will happen at anode? The oxygen loses 4 electron, 2 oxygen loses 4 electron, and it will form oxygen gas. This was the equation for anode and cathode. The problem in electrolysis is the temperature. Which is too high. So how I can reduce the temperature, the melting temperature? Because to melt aluminum oxide, I should supply too much energy or maintain a temperature which is 1900 degrees centigrade. So what I should do to lower the temperature, the melting temperature? So if I add water, then it will not be useful. Why? Because then hydroxide ion will move. So to lower the temperature, to decrease the temperature, we add impurity, because whenever you add impurity, impurity will lower the temperature. And what we add impurity? We add impurity known as cryolite. Cryolite is a compound which is having a formula Na3Al. This is Na3AlF6. This is a formula for cryolite. So we add cryolite or we add impurity. What is the advantage of adding a cryolite? What is the advantage of adding a cryolite or impurity? So it lowers the temperature. That's one thing. Melting point. Second thing, because you can see here cryolite contain You can see here the cryolite contain many atoms, like there is sodium, aluminium, fluorine. So what it will do, it will increase the conduction of the electrolyte. We are not lowering a temperature. What happened when you have when you have a pure aluminium, when you have pure aluminium oxide, its melting point is equals to 1900 degrees centigrade. But when you have impure aluminium oxide, its melting point is 980 degrees centigrade. So it can melt at around 980. So what is the advantage of adding a cryolite? Because impurities always lower the melting point, so it can melt at lower temperature. There are many types of impurities can be added, but cryolite is the best impurity to add to this. Reason for that, you can see here. Number one, when we add impurity, it lower the melting point. Number two, you can see cryolite contain many atoms. Many ions are there. There is a sodium ion, aluminium ion, and fluorine ion. So as the number of the ion increase, the conduction will also increase. And then there is another advantage of adding cryolite. You can see cryolite also contain aluminium. So it increases the amount of aluminium as well. So these are the three advantages of adding a cryolite. So what happened if you was having a pure aluminium oxide, you have to supply energy and the temperature, you should maintain a temperature about 1900 degrees centigrade. But if you use impure aluminium oxide, impure aluminium oxide here refers to aluminium oxide with by addition, but here impurity we are adding, we add a cryolite. So what is the advantages of adding a cryolite? It lower the melting point. It will increase ions in electrolyte, which help increasing the conduction, and it increases the amount of aluminium as well, because cryolite also contain aluminium. So there will be more aluminium ions in the electrolyte. Is it clear? So at the anode, what we observe the carbon dioxide is also formed. But the question is how a carbon dioxide is formed at anode. Yeah, that's right. Not melt, basically melting temperature of a graphite. One of the student asked this, that why even the temperature is 1900 degrees centigrade and the graphite is not melted, because the melting temperature of a graphite is 3600 degrees centigrade. So graphite will not melt at 1900, but at anode, the carbon dioxide is also formed. How? Because due to high temperature, even 980 or 1900, these are high temperature. So due to high temperature, carbon of anode reacted with oxygen forms carbon dioxide. Is it clear, the extraction of aluminium? Reaction of aluminium with acid. Aluminium is a metal, and as you know, if I generally write an equation, metal plus acid, what is the result? Metal plus acid. Whenever any metal react with acid, it will be salt and hydrogen. Salt plus hydrogen. Okay, so hydrogen is a gas which is given off. So if I sketch a graph for volume of a gas and time, volume of hydrogen, and with respect to time. So in the beginning, it will be steeper slope because more particles are there. And with the passage of a time, the rate will decrease. Eventually, amount of hydrogen will be constant, means the reaction stop. That is the normal graph for obtaining the reaction from, obtaining a hydrogen from reaction between metal and acid. But if we take an aluminium, like if this metal was specifically aluminium, it will give salt and hydrogen. But if I sketch this shape of the graph, it will be a bit different. It is like this. First, in the beginning, it is slow. Then it speed up, then it will become fast, and then again it will slow down, and eventually it is zero. If there was, the blue line is representing aluminium and the black line is representing other metals. So for other metals, in the beginning it is fast, then it slow down, and eventually it is zero. But with aluminium, it is a bit different. First, initially it is slow, then it speed up, then again it slow down, and eventually it will be zero. Any idea why it is like this? When a metal react with acid, it will give salt and hydrogen. In the beginning, you will have steeper slope, shows the faster rate of reaction. But with the passage of a time, the rate of reaction decrease, so slope decrease, and eventually it will be constant. So in the beginning, you will have fast reaction, then it will slow down, and eventually it will stop. This is with normal metals. Aluminium is also a metal, but with aluminium, the graph is a bit different. So what happened? Yes, Afif, you are right. So what happened with aluminium? In the beginning, it is slow, then it becomes fast, and then again it slow down and stops. So in the beginning, the reaction with aluminium is slow, then it becomes fast, then it slow down, and then it will stop. So what is the reason why in case of aluminium, it's a bit different? Because what happened when you have a piece of aluminium, like if I say this is aluminium, a metal aluminium, aluminium metal reacted with atmosphere, and when it reacted with atmosphere, it will form an oxide layer or at the surface. So this oxide layer protect the aluminium from reaction with acid. That's why oxide does not. So what is the reason why in the beginning the reaction is slow? Because aluminium contain an oxide layer. The shaded part is representing the oxide layer on aluminium. So aluminium contain an oxide layer which does not allow slowly with acid. Once the oxide layer is removed, the reaction speed up. So due to the oxide layer, reactions of aluminium are slower, and aluminium is giving greater amount of hydrogen as compared to other metals, because when you write an equation, if I say zinc is reacting with hydrochloric acid, so zinc plus hydrochloric acid, it will form zinc chloride plus hydrogen. This is a balance equation. But when aluminium reacted with hydrochloric acid, it will form aluminium 3 chloride or aluminium chloride plus hydrogen. When you balance this equation, this is a balance equation for this reaction. So you can see here aluminium is giving 3 molecules of hydrogen, where other metals normally group valency of +2 metals, they give only 1 molecule. That's why the final volume of hydrogen is higher than other metals. But that is according to the equation you can identify from equation. That's not the main question. The main part of the question is why the aluminium reaction is slower in the beginning, but as with the passage of a time, the reaction increases. So what is the reason for that? Number one, aluminium is having an oxide layer, which is a protective oxide layer, does not allow aluminium to react with acid, or the reaction of acid will be very slow. That's why the reaction in the beginning are slower. With the passage of a time, once the oxide layer is removed, then the aluminium is exposed to the acid and the reaction speed up. That's why the rate of a reaction also increases. Is it clear? Why reaction of aluminium with acid are a bit different compared to other metals? So what happens when you have a piece of the metal, aluminium, aluminium react with surrounding. So aluminium react with surrounding oxygen, and it will form aluminium oxide. So top layer of aluminium is actually not aluminium, it is aluminium oxide. And aluminium oxide does not react easily with acid, it reacts slowly with acid. That's why in the beginning, the reaction is slow. Why the reaction is slow in the beginning? because the acid was reacting with the protective oxide layer on the surface of aluminium. Once this oxide layer is removed, if this oxide layer is removed, then what will happen? Then the aluminium is exposed. So when the aluminium is exposed, then aluminium will react with acid and the reaction will speed up. Is it clear? No, actually what happened, for other metals, they turned completely. Like in case of aluminium, it's only the surface turned into aluminium oxide. But for other metals, if they are exposed to the atmosphere, they will turn into metal oxide. The complete metal will turn into metal oxide. But in case of aluminium, only the surface turned into aluminium oxide. The aluminum oxide layer does not react with aluminum. Oxygen react with aluminum, form an oxide layer, and this oxide layer is not reacting with aluminum. This oxide layer react with acid. For normal metal, like example, if I say you have a copper or you have, say, magnesium. So this is magnesium. So when we say we have a magnesium, this happened with magnesium as well. So for what happened to the surface of the magnesium? It is covered with, it reacted with oxygen and it will form magnesium oxide. And oxide reactions are slower. So if the metal is not reacting very fast, so means it has an oxide layer. Some of the oxide layer develop quickly, some of the oxide layer take time to form. Like example, oxide layer of iron take too much time as compared to aluminium. Is it clear now, the concept? So if the metal is having an oxide layer is formed for other metals also, but the thickness, the size of the oxide layer also define the inertness of the metal. So there is a question related to this extraction of aluminium. And before that, I want you to copy this table. Then I will discuss a question as well. Not all of it, only the first three part I want you to write. Does not corrode, so we can use as a food container. Low density and unreactive, so we can use in or pack the packing buildings we can use. And one more thing, low density. So we can use for aircraft body. copy these four properties and the uses, because sometimes you will find a question in which they ask state the property and the use based on that following property of aluminium. So basically what happened, why aluminium is not extracted by heating aluminium oxide with carbon, because if you have aluminium oxide and you heat it with carbon or carbon monoxide, this carbon is not able to displace this aluminium because carbon is less reactive. So actually there is no reaction. The next one, aluminium oxide is an ionic compound which has high melting point. Complete the dot and cross diagram to show the electron arrangement in one oxide ion.